Good afternoon. Today we are factoring general trinomials. And I'm also putting in parentheses here the game, because the first step we make in the process of factoring a general trinomial is something I like to call the game. So first I'm going to show you what I mean by the game, and then we'll incorporate it into factoring a trinomial. So the game is find two numbers that have a product of something that I'm going to put right here, and a sum of something that I'm going to put right here. And the two numbers that satisfy whatever product and sum I put here we'll call the winners. So can you think of two numbers who have a product of 6 and a sum of 5? Okay, it's a pretty easy example. Both numbers are positive, that's why it's pretty easy. The winners are 2 and 3. Okay, we'll play it one more time. Find two numbers who have a product of 12 and a sum of 7. And that would be 4 and 3. And now I'm going to make it a little bit more complicated. So how about a product of 30 and a sum of -11? So this is possible because if a product is positive, the two numbers, the two factors of that product could both be negative. They don't both have to be positive. And if they're both negative, that means their sum will also be negative. So here the answer, the winners are -6, -5. Now this time I'm going to make the product negative. So two numbers that have a product of -8 and a sum of 2. Product -8, sum of 2. So that means one of the two factors of -8 has to be negative, the other one is going to be positive. And the sum is 2, so that means the positive one has to have a bigger absolute value. So this time the winners are 4 and -2. Okay, one last example. Find two numbers who have a product of -7 and a sum of -6. Product -7, sum of -6. So again, since the product negative, we have to have one positive, one negative number. The one with the higher absolute value has to be negative because the sum is negative. The winners are -7 and +1. Okay, so that's the game. That's the game. And we're going to use this game in the first step of factoring a general trinomial. Now what's a general trinomial? A general trinomial is basically any trinomial. Any trinomial. Not just perfect square trinomials. Because as I've said before in class, we have perfect square trinomials, but we also have many trinomials that are not perfect squares. And just because they're not perfect squares doesn't mean they can't be factored. Many general trinomials, non-perfect square trinomials, can be factored. And we're going to use this multi-step process. So ax squared plus bx plus c represents a general trinomial. The coefficient of x squared could be anything. B could be something, and the constant could be something, okay? So this represents all the non-perfect square trinomials out there. So to factor a general trinomial, the first thing we do is, I'm going to start a list of steps here. The first thing we do is multiply A and C. So that means the coefficient here and the constant here. And we do this on the side. So we find out what A times C is. Okay? So I'm just going to put in parentheses here, we get AC, whatever that is. The second step is we play the game. The game that we just played up here. So that means we need to know, okay, I'm looking for two numbers, but what product do I want and what sum do I want? So I want two numbers who have a product of AC. That's why I multiplied A and C in the beginning. This is the product I want when I'm playing the game. And I want my two numbers to have a sum of whatever B is. Okay, so I play the game and I get my winners. I'll call the winners just W1 and W2, okay? Now, I do something called splitting the middle term. With the winners. Okay, this is what I mean. Okay, I take my trinomial, I do the first step. I multiply A and C, I get some number. I look at B, and then I play my game. I get the winners, W1 and W2. And then I split the middle term with the winners. So what I do is, I write Bx as W1x plus W2x. So what was a trinomial has become a four-term polynomial. Now why would I do that? It feels like I'm unsimplifying because I'm going from 3 terms to 4 terms. Seems like the opposite of what we've been doing. But there's a good reason I do that. In the last video, we factored 4-term polynomials, right? This is why we did that. There is a way to factor this 4-term polynomial. And that's what I'm going to do next. So after you split the middle term with the winners, look for a GCF in the first 2 terms. And a GCF in the second 2 terms. Here. And then take it out. Now here I'm going to actually use numbers because I think it's easier for this lesson to use real numbers. So I'm going to use x squared plus 7x plus 10. Okay, step 1. Multiply A and C. A is 1, because that's the coefficient of x squared. C is 10. So AC is 10. I'm going to write that on the side. Then I look at B. That is 7. So now I play the game. I want 2 numbers whose product is 10 and whose sum is 7. The winners are 2 and 5. So now I split the middle term with those two winners, 2 and 5. So instead of 7x, I'm going to write 2x plus 5x. There's the split. I now have 4 terms, and now, like step 4 says, I look for the GCF of these two terms and a GCF of these two terms. The GCF in the first two terms is x. I take the GCF out. The leftover is x plus 2. The GCF in the second two terms is 5. I take it out. The leftover is x plus 2. Same leftover. Now, step 5, I look for a big GCF. There it is, x plus 2. I take it out, and the leftover is x plus 5. I have a product of two binomials, and if I want to, I can FOIL it just to make sure that I'm right. I get x squared plus 5x plus 2x plus 10, and that is x squared plus 7x plus 10. So I did it right. Now, if you make a mistake along the way, this process actually self-corrects, because if you do something wrong from somewhere in here, then that big GCF will never appear. You'll get two different binomials as leftovers, and you won't have a big GCF. And that'll tell you that you did something wrong. Okay, so that self-corrects. All right, let's try this one more time. Two x squared plus 11x plus 12. Okay, my first step is to find what AC is. A is 2, C is 12, AC is 24. B is 11. Okay, so now I'm playing the game with 24 and 11. I want a product of 24, and I want a sum of 11. What are my two winners? My two winners are 8 and 3. So now I will split the middle term with my two winners. I copy down the 2x squared. I split 11 into 8x and 3x, and I bring down the 12. Okay, I have 4 terms now, so now it's time to find GCF. GCF here, GCF here. (2x) is the GCF here. Left over, x plus 4. GCF here, 3. Left over, x plus 4, so I know I did it right. Big GCF, x plus 4. Left over, 2x plus 3. I'm done, and if you want to double check it, you can FOIL it. You will get 2x squared plus 11x plus 12. Okay, this factoring method is the longest one because it takes about 5 steps. The longest one that I've shown you so far, but it is, and also it's based on lots of other techniques that we've done before. You need to know how to find big GCF. We've done that before. You need to know how to find a GCF of two terms. We've done that before. Okay, so you can't forget the other techniques. We are incorporating two techniques in this new one. And you got to know how to play that game. Okay? Okay, so that's factoring trinomials. You may also hear me refer to this method as splitting the middle term. So when I say split the middle term, I'm talking about this multi-step process. Will all trinomials factor like this? Yes, all trinomials that are factorable, you can use this method on. For trinomials that are not factorable, that are prime, then of course this won't work. In fact, if you try to factor using this method a trinomial that is prime, let's say this trinomial, what'll happen is when you play the game, and try to find the winners, there are no winners. There's no such pair of integers where the product is 8 and the sum is 5. They just don't exist. In fact, I don't even think there's a pair of fractions that would work. So that if winners don't exist, then that trinomial is prime. Okay, that's factoring general trinomials using the method splitting the term involving playing that number game. See you next time.